Hi everyone, welcome into this video lesson on dimensional analysis. Dimensional analysis is also known as the factor label method, and it is simply a tool to make complicated problems a lot easier to solve. It's a system for solving problems, and in chemistry it'll be your main tool for solving most of the problems that you face. Dimensional analysis also, though, has a lot of useful applications in everyday life. So it will serve you well to know dimensional analysis, both for getting through chemistry and for everyday life. So in science, we're trying to get to know nature. And scientists try to understand nature by making measurements and comparing them. We measure the physical quantities around us. So these things that we could measure, for instance, might be time or distance, mass, volume, weight, energy. There are a lot of these quantities that we can measure in the physical world around us. We call these measurable quantities dimensions, and they are the dimensions of what we can experience in life. And the things that we can experience, the things that affect us, that's what we want to know about, and those are the things we ask questions, that we measure, and that we compare. So these dimensions, or quantities, can get expressed in different ways. For instance, some volume of a solution, and we might measure it to be 1.45 liters of solution. However, we could express that also as gallons, as cups, milliliters. That's a certain number of ounces as well. And dimensional analysis is the tool that lets us convert between these units. It lets us say, well, 1.45 liters is the same thing as 0.383 gallons or 6.13 cups, 1,450 milliliters or 49 ounces. Dimensional analysis makes the conversion between these expressions very easy. Now, it's not just about converting units of a particular measure. It's also about taking one unit and using it to find out something completely different, because all of the physical quantities in nature, all of the dimensions that we can experience, they have relationships to each other. And so dimensional analysis allows us to use these relationships to convert between units of different quantities. So for instance, I could talk about the mass of sugar. I could say it's 4 grams of sugar, but I could also talk about the amount of energy that's in that sugar. Dimensional analysis would allow me to convert between the mass of some sugar and the amount of energy that's in it, using the relationship between the energy and the mass of sugar. Here's how it works. It uses these magical things called conversion factors. If you have some given amount and you want to turn it into something else or find out something else from this amount, you take that amount and you multiply it by a conversion factor. Conversion factor won't change the actual amount that you're talking about, just how you're talking about it. Now, conversion factors, they are fractions. So the first thing you need to know, a conversion factor is simply that. It's a fraction. It has a numerator and it has a denominator. What's critical about conversion factors is that the numerator on top and the denominator on bottom are two equivalent amounts. They have to be two equal amounts. They have to be two equal amounts. Consider these 3 conversion factors. All of these are fractions, and in every case, the numerator is equivalent to the denominator. Now, we're going to practice with some examples here in a second, and to do this, I have listed out some steps for dimensional analysis. If you go to mrsexton.com, click Unit 1 for chemistry, scroll down to conversion problems, and you can find these steps there for yourself. So our first example, we're going to take this quantity, this dimension, 57 days, and we want to express it in different units. So we're going to do this twice. First, we're going to express 57 days in terms of years. How many years are in 57 days? Then we're going to go the other way, and we are going to express are 57 days in terms of minutes. Okay? So, step 1 of dimensional analysis says make sure you read the question very carefully. You should read it more than twice. And in these examples, these are really simple examples, so if you don't spend a lot of time reading that, it makes sense. But later on, the problems get very complicated. There will be all sorts of different numbers in there. Sorting through which ones to use for what is going to be difficult. And in those situations, you need to use your language skills, and you need to read that thing carefully, slowly. And little words like and versus or, they make a big difference. So pay attention to all of that. What you're doing when you're reading is you're looking for 2 things. So step 2 says make sure you know where you're trying to go. Make sure you understand what units you want your answer to be in. This is what the question is asking for, so make sure you know what it's asking for. If you don't know what you're trying to get, you probably aren't going to get there. So, step 1, make sure you know what we're trying to get. And in this question, express the quantity 57 days in years. I recognize that this problem is asking me for a number of years. So when I'm all done, I will have years. That's what I'm trying to get. I'm trying to get to years. In terms of where I'm starting, it's pretty obvious because there's only one number in here, 57 days. But later on, when there's a lot of different numbers in the problem, you've got to read carefully and figure out of all those numbers in there, which one is the one that will determine my answer or determine my number of years. Which one does the number of years depend on? Okay, where are these years coming from? You've got to try to think of it in a few ways like that to figure out what that starting amount is. Very easy in these problems, but later on, step 3 will probably be your most difficult step. Keep that in mind for later. Okay, so step 4 is where the pencil hits the paper. Step 4, we want to take this given amount that our answer depends on and write it as a fraction. So, there's an easy way to write any number as a fraction. I'm going to write 57 days, and then I'm just going to put it over 1. And now it's a fraction. Now in chemistry you can do that even if it said 57.3 days. You can still put a decimal up here in the numerator and put it over 1. Your math teacher might freak out and chase you around with a red pen trying to mark it up, but it's okay in here. Alright? This is just for dimensional analysis, it's not arithmetic. Just a 1 down there. There are situations where this won't just be a 1. There are times where there's going to be a unit down here. And the key is to listen for when the kitty cat is happy. When the kitty cat's happy, it purrs. When you hear purr, it tells you there's something down here. Like if I said 75 miles per hour. That's 75 miles per hour means there's 1 hour down in the bottom. Per means for every 1, or divided by 1. Divided by goes in the denominator. Okay, so we've expressed this given amount as a fraction. Step 5, easy one. Don't forget to do it. Times in a line. Just write times and a line. If you think you're stuck and you haven't written times in a line, you're not stuck yet until you write times in a line. This is here to help you think. It's guiding your brain. It's opening up a pathway to get you to think, okay, I'm building a conversion factor. This will be my conversion factor. It'll be a fraction of 2 equal amounts. I have days here. I want years. It's not just about getting years. You also have to get rid of the days. So algebraically, you should recognize that if I have days in the numerator and I want them to cancel out, putting them on the opposite side of the divisor in my conversion factor, denominator, I've got days divided by days. And anytime you have something divided by itself, it becomes 1. So in essence, days has canceled itself out. I'm not worried about any numbers yet. What I want are years, so I'm going to put the years up in the numerator to replace the days that I had in the numerator. You can really put anything you want to go to up here as long as you know you'll be able to find an equal amount for this number and this number. So when you're doing your chemistry problems, spend some time sifting through that problem, reading, and look for equivalencies. Look for things where the text is telling you this is equal to this. These two amounts go together. And in those cases, you can build conversion factors. Now, I do know a number of years and days that are equal, so I'm going to go ahead and put years up there and get going. It usually helps to put a 1 by the bigger unit. It's easier to figure out how many inches are in 1 foot than it is to figure out how much of a foot is in 1 inch. So if you put a 1 by the bigger unit, you'll never have fractions or decimals or negative exponents. So in days, that's 365.2 days is in a year. Now, if you're wondering about the 0.2, we're not going to get all astronomy here right now, but this is why we have a leap year. The Earth travels around the sun in 365 days, and a little bit more to finish that full lap around the sun. So, anyways, I can hit equals now because I've canceled out my days, and I have years here in the numerator where I want them. All I got to do is the math. Dimensional analysis allows you to set this thing up. As long as you can cancel out your units and find equal amounts, it allows you to set this all up, look at it, and you don't have to worry about math. You don't have to rack your brain, should I be multiplying? Should I be dividing? You just look at this, and it tells you, get out the calculator, let the calculator do the heavy lifting for you. Whatever is in the numerator, multiply by it. Whatever is in the denominator, divide by it. That's the last step on the dimensional analysis steps that I showed you. Multiply all the numerators, divide by all the denominators. Any order you want, order of operations, doesn't matter because it's all multiplying and dividing. Okay? So I'll take 57 days. Multiplying by 1 is not important. It won't change anything. You can skip the ones. Dividing by 1 doesn't change anything. So it's 57 days. Since this is in the denominator, I'll divide by that. So get out the calculator, and 57 divided by 365.2 is 0.156. I only have 2 figures in this starting amount, so I'm going to round my answer to 2 figures. So a 156 becomes a 0.16 years. So 16/100ths of a year is the same thing as 57 days. All right, now let's take it the other way around, following the same steps, but we're going to turn this into minutes now. So, again, express the given amount as a fraction. 57 days, put it over 1, it's a fraction, times in a line. Okay. Step 6 says, get rid of the units that you have by putting them on the opposite side of the divisor, and the units that you want on top. Now, I want minutes. Problem is, off the top of my head, I don't really know an equal amount for days and minutes. So I'm not just going to straight put minutes here. I need to think of myself, what do I know that's equal to days? Where can I go? And so an easy relationship to remember is that 1 day is 24 hours. So now my days have canceled out, and I'm left with hours. If I stopped and did the math, I'd have hours, but I want minutes. So simply times in another line. Now, we're trying to cancel these hours out. So if I put them on the opposite side of the line, they will cancel as well. Can I come up with an equal number now for minutes? I can. Put minutes. 60 of those is 1 hour. So, math time. Simply look at it. It's telling you, take 57, multiply it by 24, multiply it by 60. All the denominators are 1. So if you do that correctly, you should get 82,080 minutes. So 82080 minutes. Same thing as 57 days. Okay, now let's move on to another example to deal with compound units. This is what happens when the kitty cat's happy and you hear the purr. It means that there will be units in the denominator of your given amount. So this question says, express the speed 55 miles per hour in units of meters per second. Okay, so we've read the question carefully. We need to make sure that we know where we are going. What do we want when we're done? What's this question asking for? Hopefully you recognize that it's asking for meters per second. So over here, where I'm done, I will say meters over seconds. What we're trying to turn into those meters per second are the 55 miles per hour. So over here, I'll express my 55 miles per. You hear that? When you hear the per, that means there's something in the denominator. Per hour is for every 1 hour. So that's how you would express 55 miles per hour as a fraction. 55 miles over 1 hour. Okay? Step 5, remember what step 5 is? Times in a line. Now, we've got two things to convert here. I need to turn these miles into meters, and I need to turn these hours into seconds. Don't try to do them at the same time. You're going to do a different conversion factor for each one. Take them one at a time. You can choose either one to start with. So I'm going to go ahead and start with miles. I want to cancel out the miles. I don't want miles. So put them on bottom. That's going to cancel out my miles. I can go anywhere if I know an equal amount. So do you know how many meters in a mile? You might not think you know this, but you probably do if you've spent any time around a track, running PE. Think about this. How many laps do you have to run on a track to run a mile? 4 laps is a mile. If you were to run just 1 lap, how many meters is that? Most people know that's a 400. So 400 meters in 1 lap, 400 times 4 laps is 1,600 meters, and it's also 1 mile. So look for equivalencies, okay? You might have to look it up to find an equivalency. They're all around you, though. They're hiding in different places. If you look on food labels, it will tell you how many grams, and it will also tell you how many ounces are in a certain package. If you look on a bottle of water, it'll tell you it's 16.9 ounces, and it'll also tell you that it's 500 milliliters. You can make a conversion factor. 16.9 ounces, 500 milliliters, they're 2 equal amounts. Conversion factors are just fractions with 2 equal amounts. Okay? So find the equivalencies to help you out. Now, I've canceled out miles and I have meters here. But I have to deal with my hours. So I'm going to go times in another line. I don't want hours. Notice that they're in the denominator here. To get them to cancel out now, I'll have to put them in the numerator on the opposite side of the divisor. So I'll put my hours up there to cancel those out. I can turn those hours into anything as long as I know 2 equal amounts. Now, if you don't know how many seconds are in an hour, turn your hours into minutes, then turn your minutes into seconds. Okay? You may know that 1 hour is 3,600 seconds, 60 times 60. And don't forget to write the units, seconds. So this is telling me now, I've got meters up here that haven't canceled out. I've got seconds down here that haven't canceled out. Everything else has. So the units that are left are just like the units that I want. Meters on top, seconds on bottom. Just do the math. Multiply all the numerators, divide by all the denominators. So I will simply go 55. I'm going to multiply by 1,600. And then I'm going to divide by 3,600 because the 32.4 meters per second. Okay. Now, I've got one last example that I'd like to go through with you, and it's a special case of doing a conversion factor that has the same base unit. So for instance, going from grams to kilograms, going from milliliters to deciliters. In this case, our example is kilometers to micrometers. In both cases, the base unit is meters. I've got kilometers and micrometers. When the base is the same, you can do some tricks to speed things up. Okay? So, first thing you need to do, write the given amount as a fraction. I've got my 4.37 micrometers. Express it as a fraction times and a line. No, I don't want micrometers, so you should recognize they'll have to be in the denominator of my conversion factor. Now, if it's a base to base, same base metric conversion, you can do this in one step every time, okay? So go ahead and assume that you can get to kilometers in one step. All right. Now, for this situation, there's really two tricks. Okay, the first trick is to make sure that you put a 1 with the bigger unit. Again, it's a lot easier to figure out how many little things are in one big thing than it is to figure out how much of this big thing is in one of these little things. Okay? So, kilometers are bigger, so I'm going to put a 1 with the kilometer. What if you didn't know whether or not kilometers were bigger than micrometers? In that case, you need to remember this phrase. Right here. Kids have dogs, but don't care much. Cat says mew, but not neigh. Kids have dogs, but don't care much. Cats say mew, but not neigh. And if you list the first letter of either all of those in order, they stand for the metric prefixes. The furthest one up is the biggest one, and since K is up here, and the Greek letter mu for micro is way down here, I will go ahead and put a 1 with K, because it's further up, it's bigger. All right? Don't forget that. If you remember that step, then the next thing that you can do is simply count the number of jumps from the K all the way down to the mu. So you start on the K and you just count the jumps. So 1, 2, 3, 4, 5, 6, 7, 8, 9 to get to mu. Notice I counted the dashes there for cats say. 9 jumps. You're going to write 10, and the power will be the number of jumps, so 10 to the 9th power. As long as you put a 1 with the bigger unit, you will always have a positive exponent. It will never be a decimal or a negative exponent. You'll never have to worry about whether you're counting up or down through the prefixes. Simply count the number of jumps, and this tells you take 4.37 and divide it by 10 to the 9th power. If you do that, you'll get a very small number of kilometers. 4.37 times 10 to the negative 9th kilometers. Okay? You can have your calculator do that, or if you know how to deal with the exponents, do it on your own. All right. I hope that made some sense, and certainly if you have questions, feel free to send me an email, make comments on the Unit 1 page of MrSexton.com, or make comments on the YouTube page for this video. You guys have a good day.